Polynomial and rational inequality. We're going to solve inequality problems here. For example, let's say you have 3x plus 5 is greater or equal to 0. How do you solve it? This is a polynomial. So to solve this, we are going to use the same process like we used to solve linear equation. You have to subtract 5 from both sides, and that gives you 3x is greater than or equal to -5, and then if you divide both sides by positive, the inequality holds, meaning the same inequality you are going to see. So the answer is anything greater than or equal to -5/3 would be solution. So if you go to the real number line, find out -5/3, the answer for this inequality is anything including this number and greater. So that means it goes to the right side. So bracket -5/3 comma infinity. So the solution for inequality would be interval like this. So this is one example of polynomial inequality. You can do the same thing for rational inequality. Okay, so although the functions like linear function, quadratic function can be solved using the very same process, we can set up the inequality and solve the very same way I did before. Some of the examples: this is a degree 4 polynomial, this is a linear, this is cubic. You have to bring everything on the one side and then solve the inequality. Okay, so these are the some helpful tips. Find an equivalent inequality with p of x on one side and then 0 on the other side. So meaning bring everything on the one side and just put the 0 on the other side. And now solve the related polynomial equation, like solve it like you are solving the equation. Use the solution to divide the x-axis into the intervals. Then select a test value from each interval and determine the polynomial sign on the interval. Oh, okay, so this is either you can use the way I did here, this example, or you can first find the solution of the equation, and then after finding the solution, that means it gives you the x-intercept. For example, in this question, if you convert that inequality into equation, the solution would be x equal -5/3, and find out that x-intercept. And now you have two intervals from -infinity to -5/3, or from -5/3 to positive infinity. And now you check where this function is positive. You pick something from here and then test, and if you pick something from here and test, wherever this function is positive, you choose that interval as your solution. That is what they are saying in these steps. Okay, now always your solution would be in interval notation. We try to do the same thing for the rational inequality. First of all, find an equivalent inequality with 0 on one side. Change the inequality symbol to an equal sign and solve the related equation. Find the value of the variable for which the related rational function is not defined. The number found in step 2 and 3 are called critical values. 2 and 3, where you have the rational function 0 and where the rational function is undefined. Use the critical value to divide the x-axis into the interval, then test an x value. So I'm going to show you how to follow these steps by using some examples. Let me choose some problem from, let's say here. This is first question. Solve this inequality. This is quadratic inequality. So just copy that, just convert that into equation. So this is x squared minus 14x plus 45 is equal to 0. Solve this quadratic equation. I can factor this. I just need to find two factors of 45 such that the sum of those two factors are supposed to be -14. and they are -9 and -5, because -9 times -5 is positive 45. But if you add -9 and -5, that will give you -14. So by using those two factors, the solution for this equation are +9 and -5, or +5. So these are the two solutions we found, the x-intercept +5 and +9. But this is not the solution of the inequality. This is the solution of equation. For finding the solution of inequality, you change this real number line into 3 different intervals: -infinity to +5, +5 to 9, and 9 to +infinity. And you pick a testing point from each of them and test where this function would be positive. So remember, this is the function. Let's say from here you pick a testing point 0. Always pick a easy testing point. So this is the function. Let's say if the function is x squared minus 14x plus 45. If you try to find the value of this function at 0, it would be 45. So on this interval, the function, this quadratic function, would be positive. So there is greater than 0. That is positive. So this is a part of the solution. We need to do the same thing for here. Choose something greater than 5, let's say 6. Find out the value of the function at 6. So the value of the function at 6 would be 6 squared, which is 36, minus 14 times 6, which is 84, plus 45, and that would be greater than 0 as well. 6, yes, 6, no, it's less than 0, because 45 plus 30 is 75, plus 6 is 81. So it's 81 minus 84, which is -3, which is less than 0. So on this interval, the function is negative. Do the same thing here. Pick something like, let's say 10. Find the value of the function at 10. It's a 10 squared minus 1. 14 times 10, which is 140. So 100 plus 45, 145 minus 140 is positive. So at 10, the value of the function is positive. So on this interval and on this interval, the function is positive. So both of them are part of the solution. So how do you write it? The solution would be -infinity up to +5, and then union, so +9 to +infinity, +9 to +infinity. Keep in mind, because the inequality doesn't have equal sign here, so we do not include these zeros. So that's the reason we have this parenthesis instead of bracket. So let's do another one. This is a rational inequality. So first of all, type that inequality as an equation, so greater than equal to 0. So solve this one. Find out where the denominator is 0. So at x equal to -8, this function is undefined. So that is one point which we find, that's called critical point. And if you take the the numerator, which is 7x equals 0, that gives you another solution, which is 0. So there are two critical values. If you check the notes, it says change the inequality symbol to this equation, and then find the value of the variable for which the related rational function is not defined. Solve the equation, the top part, and where the function is not defined. Both of these points are called critical value. So here in this problem, the critical values are -8 and 0. So now we're going to do the same thing. We're going to check where this rational function is greater or equal to 0 on these three intervals. So first interval is from -infinity to -8. Second one is -8 to 0. Third one is 0 to +infinity. So pick something from here, the testing point, let's say -7, that's the testing point. And the rational function is 7x over x plus 8. If I try to find the value of this function at -7, it would be actually negative. So that is a -49. So it's negative here. on this interval the function is negative, so this is not the part of the solution. But yeah, this is not the part of the solution. We have to include 0, so you use the bracket wherever you see the 0, because here you see the inequality sign, it has greater and equality, so whenever you see the equality you put the bracket at zeros. So we check the first interval, it failed. Now we're going to check the second interval. We're going to pick something from here on this interval. Let's say you have -1. Find the value of the function at -1. So the value of the rational function at -1 is, this is the function, 7 times -1, -1 plus 8, which is -7, and then +7, which is negative again, -1. So that is also not a part of the solution. Now we pick something from here which is greater than 0. So greater than 0, let's pick 1. At 1, it's 7 times 1, 1 plus 8, which is 7/9, which is greater than 0. That's the reason the solution of this rational inequality is the third interval, which is including 0 and go up to +infinity. So that's the solution. What happened? Let me go back and check. 0 to infinity. Here I put negative, that was still positive. Negative, that was still negative. I put negative. Oh, do you see the mistake I did? From here I picked -7, but -7 is not part of this interval. It's supposed to be here. This is supposed to be something less than -8, which is not -7. -7 is greater than -8. That's the mistake I did. I supposed to pick, let's say, -9. And let's find out the value of the function at -9. So at -9, it's 7 times -9, -9 plus 8, which is -63 over -1, which is +63. So what I did, mistakenly, I picked -7 from this interval, but -7 is not part of this interval. So the function, the rational function, is supposed to be greater than 0 here on this interval as well. So I have to add here one more interval, which is -infinity up to, what is that? Up to -8. -8, and then parenthesis close. I cannot include -8 because at -8 the function is undefined, so I cannot include -8 in the solution. Now it works. So keep in mind, always double check your work. I did a mistake here. I mistakenly picked -7 from this interval, which is not the part of the interval. Okay, let's let's look at the last question. From the graph, this is the graph of the function. Find out the solution of this. To find the solution from the graph, just bring everything to the one side. So I'm going to copy that x cubed plus 7x squared. If you bring that 9x and then 63 to the other side, we would like to find out where this function is negative, and we are told that the graph of the function is this. So we just have to find out where this graph is negative. So as you can see here, this is 0, 2, 4, 6. This is -7. So to the left of -7, the function is negative. From -3 to +3, the function is negative. So you see the graph. So from -infinity up to -7, because this point is, this is 0, 2, 4, 6, 1, 7, up to -7, and that's the graph is negative. And from -3 up to +3, the graph is negative. Graph negative means the graph is below x-axis. So we're not including 0, so that's supposed to be -3 to +3. So that's the reason we have parentheses instead of bracket. Fantastic. And that's all for this section.